right, 4.7 optimization. This is going to be the last example I'm going to go over. You're always going to see stuff like this on the AP exam. There's always this problem on here. Okay, because of this, a rectangle is inscribed in a semicircle with a radius of 2. Okay, find the dimensions of the rectangle that has the maximum area. Okay, so what would be the area of this? Okay, how would I find the area of that? Shaded in blue. So, area 2x times y, right? Okay. And so I have domains on this also. So x cannot be what?
0.
Okay, so x has to be, it has to be between 0 and 2, right? Yes? Bless you. It has to be between 0 and 2. What about the y? Bless you.
Thanks.
0 and 2 again, right? Because this is a semicircle. It's half a circle, right? So I know that the radius of this, radius, it's going to be, ah, crap. Wow, that is number 3. Okay. All right, so radius of this is going to look like that, right? And radius is going to be the same thing for any place on the circle, right? Because the radius is always going to be the same. Yes? Okay, good. All right, so we're going to maximize the area. Okay? And I know that I could replace certain values. So I know that x squared plus y squared has to equal what?
Radius 2.
2, yeah. Yep. That's helpful, isn't it? Okay, I know that it's always going to come out to be that. And so we're going to maximize the area for one of my variables. So given this, I have enough information now to actually go ahead and do this. So let's go through and what do you want to get rid of? Let's get rid of y. So we're going to isolate for y. So it's going to be y equals what? Square root of
X
no
2 minus x squared.
minus x squared. There we go. Because I got to move the x squared to the other side, right? Move the x squared on the other side. So it's 2 minus x squared, right? And then the square root of it. So now there's normally a plus or minus here, right? Why am I not dealing with the plus or minus? Yeah, so I'm not going to actually get any of those in the bottom down here. I'm always going to get the top up here. Yes? Okay, good. So now I'm going to have that. So I'm going to replace that now. So I'm going to say the area is equal to 2x times 2 minus x squared to the 1/2. All right, what rule? Because we're trying to maximize area, right? Say yes.
Yes.
I'm trying to maximize the area. So if I'm maximizing the area, I need to do what with the area?
Take the derivative.
Take the derivative of the area, right? Okay, and since I got rid of the y value, I have everything in terms of x. So let's go ahead and what rule would I use to do the derivative here? Huh? Say product. Is that what you're saying? Chain on this side right here, right? It's a product and a chain together, right? So if I were to go back through and start labeling this again, so this would be my F and this is my G, right? Yes? So f prime would be 2. Yes? G prime would be 1/2 2 minus x squared, right? To the negative 1/2 times the derivative of the inside, which would be negative 2x. Did I lose anyone on that? Because this is something we haven't done a little bit. Okay, clean that up a little bit. What's going to happen to this 2 over here and the 2 on the bottom? Those are going to cancel out, but the negative's still going to be there, right? And the x, where's the x go? If this is a fraction, where would the x go? Stay on top. It would go on top, right? Because this right here, all this has a negative exponent, so that would go on bottom. So it's going to look like this. So g prime is going to equal negative x over 2 minus x squared to the positive 1/2. Are we okay? Yes? All right, good. So I'm going to carry this over to the next slide so you guys can see this. Okay? I hate cramming all my work. So we say, what was f? And g prime? Negative x over. Okay, good. And what was just f by itself? 2x, right? And g was 2 minus x squared to the 1/2. No, right here. It's just this piece right here. So yeah, let's go ahead and I'm going to do my derivative now, right? So I'm going to say that the derivative, so dA of d, what am I taking the derivative of? This is in terms of x, right? Yeah. So derivative of a in terms of x, so dA dx, or a prime if you want to do that, but I like doing it like this, so we always state what it is that we're talking about. So it is product, so that would be 2 times g, which is 2 minus x squared to the 1/2, okay, plus g prime, which is negative x over 2 minus x squared to the 1/2 times f, which is 2x. I'll put that over 1 so we can keep track of that. Are we okay? Hopefully I didn't make any mistakes. We good? Okay, so now we gotta start cleaning it up. So I'm gonna start cleaning up. So let me see. So dA dx is equal to 2 quantity 2 minus x squared to the 1/2. I'm gonna put this over 1 so we could actually keep track of this. And this is gonna become a minus, and that's gonna be 2x squared over 2 minus x squared to the positive 1/2. Yes? Now, so we're maximizing area. So maximizing and minimizing means I need to do what next? Say it. Set it equals 0. So I'm going to set this equals 0, right? So that's going to give me mins and maxes out of it. So that means that it's going to be, that's when my slope is equal to 0, so that's a min or max. So now I get 0 equals 2 that's a half, sorry. Okay, common denominator is what I want here. The common denominator is going to be that whole thing on the bottom, right? And so if I multiply it by what I have over here, what's going to happen? What's going to happen over here to my exponents? It's going to cancel, right? So 1/2 plus 1/2 is 1 whole, right? So it's going to get rid of my radical and it's going to make it a whole. So I still have 0 equals, now it's going to give me 2 parentheses 2 minus x squared, okay, minus 2x squared all over common denominator of 2 minus x squared to the 1/2. And now from here, I want to go through and try to get rid of this. So if I set it equals 0, I need to multiply both sides of the equation by the denominator, right? Say yes. So if I multiply by the denominator, what's going to happen when I multiply 0 times anything? That goes away, right? So the whole denominator cleans up. So it's going to be 0 equals, now I'm going to distribute the top. So I get 4 minus 2x squared minus 2x squared. Yes, no? Questions? Concerns? Complaints?
I feel like I'm kind of confused.
Okay, speak. Thank you. You might not be the only one, so I need to, yes.
What are you looking at?
You? What?
Oh,
I'm waiting.
I thought you were
No,
looking
I'm waiting for other people
so,
too.
For you know the first 0, like the 0 equals over the 1.
Yeah,
And you know how you said that you multiplied it?
right here, right?
Yeah.
Okay, so yes, I'm multiplying, so it's actually going to look like this. If I'm going to go over here off to the side and actually do it here. So it's going to be 2 minus x squared 1/2 over 2 minus x squared 1/2, right? And that's going to be times my 2 parentheses 2 minus x squared 1/2 over 1, right? So that's just going to be this one side right here. Because over here, I already have that same denominator, don't I? So I don't need to multiply by anything to actually get that same thing. So when I multiply this, so it's all being multiplied together here. All this being multiplied. So when I multiply this one here and this one here, remember, if you multiply something, you add the exponents, right? So if this is x squared times x to the 5th, you get x is 7. So same rules apply, even though that they're in fractional form, and it is a binomial in there. I have a, in the parentheses multiplying by each other, I'm still going to add those together there. So it's going to be 2 and 5 gives me 7. 1/2 plus 1/2 is 1 whole. So did I answer the question?
But you said that you were going to multiply it, so why doesn't it equal to like 4 over something? Like 4.
Oh, I did multiply. When I multiply this, this, and this, just like right here, gives me 7. So, but 1/2 and 1/2, when I multiply that, I ended up getting 1 whole here. So, and I still have that 2 out front. I still have the 2 out front because it's, here's equivalent. So there's my x squared, so 3x squared, okay, times 5, or, crap. Times, where's that, x to the 5th, right? So here's the number right here, right? It's kind of like the 2 that we have in this case. So I multiply the exponents, but that 3 is still out there, right? So it gives me 3x to the 7. And that's the same thing we just did right here, because I moved it down to a 2 here, right? So the 2's there, and I just multiplied the x, right here, the exponents together. So that's how I get that first. You alright? Okay. Are you good? Yay. Alright. So, finishing up over here. Mind if can I erase this? Okay. No? Thanks. I know. Alright, so where are we at? We are right here. So I get 4 equals negative, crap. 0 equals 4 minus 4x squared. Alright, let's bring this over here. So I'm going to subtract 4 from both sides, so I get negative 4 equals negative 4x squared. So 1 equals x squared. So x equals plus or minus 1. Or square root of 1, which is just that. So I have an x value now, right? Okay, what do we got to do to try and get that y value now? Okay, plug it back in, right? So let's go back over here. So for this case right here, to maximize this, I need to maximize that y value. So let's see. So for this, I'm going to carry this over. So that's going to give me 1 squared. Yeah, so it's going to be 1, right? Y equals 1. So what is the whole area I'm going to get here? So if that's 1, that's 1, that's 1. That means that this right here is going to end up becoming what? Okay, so it's going to be 2 times 1. So the maximum area is going to be 2 units squared. Okay. Dimensions of the rectangle that has the maximum area. Okay. 1, 1, 1, 1, 1. Okay, so now, think about this carefully. You guys ready? If this is 1 and this is 1, what angle is this right here? What is it? 45 degrees. 45 degrees, or, since we always deal in radian, that's going to be what? Pi over 4. Pi over 4. Because pi over 2 is straight up and down, right? And this is going to be pi over 4. Pi over 4 is going to be the angle that I'm using there. Does that make sense? Are we okay? Okay. That's actually basically it for this one. Okay? Questions, concerns, complaints? Okay, don't forget, like, subscribe. Like I said, there's this one in the notes also, but we're not using this. It's, yeah, you're not going to see this one on their thing. All right.